Alrighty, well, welcome to a variety of quantum physics, astrophysics, space kind of video stuff, right? I'm doing a private react for an anonymous patron. Thank you to the anonymous patron who has funded my reaction to the following videos. There's 3 of them that I'm going to try to do back-to-back all in one video, as long as no technical difficulties happen. So we're starting off with the video that says Neil deGrasse Tyson explains the weirdness of quantum physics. I don't know the ins and outs of quantum physics, so this will be interesting. Let's see here. What just happened? Oh. Ooh. Ooh. Science Time. That's the name of the channel.
Quantum mechanics is the area of physics that deals with the behavior of atoms and the particles on microscopic scales.
Is that why she's staring at so it appears to be a bunch of chips from like a computer under a microscope because she's studying quantum science? I don't think so. This is obviously stock footage. She's like, this AMD processor does not sitting well into the we need more gel in here. Okay, anyway. Yeah, it's obviously stock. Pretty funny start, actually.
Since its inception, the many counterintuitive aspects and results of quantum mechanics have provoked strong philosophical debates and many interpretations.
The 1920s was the birth of quantum physics.
He's charging a Hadouken.
You can't get crazier than quantum physics. Oh my gosh. Particles pop in and out of existence. You try to measure it and it's not there anymore, but you saw it there a moment ago.
Where did it go?
And it was intriguing. Once again, it was the physicist following, the bouncing ball. Weird, crazy things were going on inside the atom. That was basic science, which at the time, surely there were people who say, what are you doing? I don't understand it. Why?
Yeah.
But we had people who were curious about the nature of the world, and they pursued it, and they were allowed to. 50 years later, we would see the birth of the information technology revolution.
That's 50 years later? Damn, that's a pretty big jump.
The word quantum derives from the Latin word for how much. In a nutshell, it looks at objects in terms of probability as opposed to certainty. In quantum mechanics, there is no such thing as absolute certainty when looking for something. This phenomenon is known as uncertainty principle and was introduced first in 1927 by the German physicist Werner Heisenberg.
Oh, Heisenberg. Interesting. The real Heisenberg. He wasn't cooking meth.
You ever, I don't know if this still happen, a quarter spills out of your pants pocket on the back seat of a car, and it's there in the wedge between the bottom and the back seat?
Yep.
And so you try to reach in to get it, and the act of reaching for the coin makes the coin move farther away from you. The act of reaching for it just slides down even further.
Correct.
That's not your mind making that happen. It's the act of the measurement that is affecting what it is you're trying to measure. And this was discovered in quantum physics, and to the point where it's the Heisenberg uncertainty principle. It's one of the basic foundations of all of quantum physics.
Heisenberg realized that one implication of quantum physics is that the act of measurement always disturbs the object measured. The uncertainty principle states that there is some inherent limit on how precisely we can simultaneously measure a particle's velocity and its position. If the uncertainty on position is small, then the uncertainty on momentum is large, and vice versa.
So you can never measure anything without affecting it. Even having a ruler and putting it up against something to measure distance in some way on a small microscopic level can affect the object or affect the atmosphere around the object and then change it. Actually, it's true. Pretty much we're in a state of flux constantly. We think we're solid, right? But in reality, there's all kinds of stuff going on at a molecular level that we don't see. It's an interesting principle.
What we observe in the world around us is not always what it seems. Classical physics, which dominates our current understanding, treats phenomena as spread out in time and space. Real-life examples of quantum physics have expanded the horizons of modern science. As Tyson emphasizes, the whole computer world is based on the principle of quantum physics. We are able to manipulate the electrical properties of silicon only because we can study the wave nature of electrons.
Interesting. Maybe that's why she was staring at that
information
motherboard earlier.
That requires quantum physics. No part of the modern economy isn't touched, because information technology requires quantum physics in the design, in the creation of data, in the acquisition, the storage, the dissemination of information. That's why it's the IT revolution. It's not a computer revolution. Computers is there. It's all about what we're doing with information. It's no longer on a printed page, here's the information. No.
Let's look at some additional examples of quantum mechanics in everyday life. Lasers and telecommunications.
Okay.
The operation of a laser is based on the quantum mechanical process of stimulated emission.
I've always been fascinated. How in the holy hell are they transmitting data through lasers? Right? Fiber optic, internet, phone lines. I don't have a clue how that works.
Anytime you use a laser, whether indirectly by making a phone call or directly by scanning a label on your groceries, you're making practical use of quantum physics. The principles of quantum mechanics have also found their application in cryptography, which allows secure transmission of information from one place to another without being intercepted. Quantum communication is another key technology that can guarantee the information security of the next global communication networks. The recent rapid growth of satellite constellation has provided impetus for the development of high-capacity laser communication in space. The work carried out by researchers at the National Institute of Information and Communications Technology in Japan have demonstrated laser communications between a microsatellite and a ground station while using the quantum nature of photons to secure the data being transmitted.
It's so wild. How are you getting a laser from space to the ground? There's got to be so many things in between interfering, right? But they found a way to make the signal so strong that it still comes through and you can still get the data. That's wild to think about.
Another satellite technology that derives from the use of quantum mechanics is the Global Positioning System.
Oh yeah, GPS.
GPS is able to tell you exactly where you are thanks to the atomic clocks aboard satellites orbiting Earth, which are set by ground control stations and synchronize themselves through signals. Every satellite is equipped with an atomic clock. Some other examples of using the underlying principles of quantum physics include fluorescent light, magnetic resonance imaging, and your toaster.
I was like, what the fuck is going on?
Our daily routines are often governed by technology that is directly related to quantum physics. Thus, our lives rest upon these fundamental scientific discoveries. However, it is worth noting that humans are not the only species that utilize quantum mechanics. A wide range of biological processes rely on quantum physics to operate.
Bioluminescence,
a perplexing property of quantum mechanics could be allowing birds to see and navigate the planet's magnetic fields.
That's true. The magnetic fields of the birds. I didn't think about that.
10,000 bird species migrate over great distances, crossing seemingly insurmountable obstacles as they follow the seasons from one place to another.
Magnetism.
Classic physics suggests that navigating such long distances should be impossible for any organism, with the feat made doubly difficult by the Earth's turbulent magnetic fields that threaten to throw a bird off course. A team of physicists at the University of California have discovered that several species of bird may be able to see the Earth's magnetic field due to quantum entanglement.
Wow, they can just see
Quantum entanglement is a hard concept to understand because it is a counterintuitive physical phenomenon. Einstein referred to it as spooky action at a distance. It occurs when a pair of particles is generated, interact, or share spatial proximity in a way such that the quantum state of each particle of the pair or group cannot be described independently of the state of the others.
So it is true, and this bothered Einstein, one of the many reasons he didn't buy quantum mechanics, because of this spooky action at a distance. It is true that I can do what's called entanglement. I can entangle two particles, like two electrons or two photons, create them in a very special quantum mechanical state, and then I can separate them from here to Alpha Centauri. And then let's say I take two electrons and I create them in states so one is spin up and one is spin down. Actually, they have opposite spins. It turns out they're spinning in all directions at the same time. Now I measure this one.
What?
And I find out it's spinning over here. It immediately makes this one spin that way. Or at least that one will be measured to be spinning that way. Immediately. So isn't that information traveling faster than light? I mean, it's instantaneous. I do this measurement here. Instantaneously, that other one collapses into that state. Before I made the measurement, they were both spinning in all directions at the same time. I measure this one, suddenly, boom, I find it's that direction. That makes this one go in that direction. Well, it sounds like information faster than light, but it turns out it's not. No information is transferred in that.
Quantum effects are not only confined to the atomic scale.
I suddenly feel really stupid. I completely lost on what they were just talking about. I have no clue.
For more than 25 years, physicists have used an exotic state of matter made from ultra-cold atoms to probe quantum behavior at the macroscopic scale. Some examples of macroscopic quantum effects are superconductivity, superfluidity, and Bose-Einstein condensates. Superconductivity is the phenomenon in which certain materials conduct electricity with zero resistance and expel magnetic fields.
Whoa,
Superconductors have
that's
an
neat.
interesting property that the resistance drops abruptly to zero when the material is cooled below a characteristic temperature.
This weird aspect of the total resistance going to zero, it took 50 years for this to be understood, more than 50 years almost. And it's a weird property of quantum mechanics. The property is that somehow, it turns out in certain materials, electrons which normally repel, in certain materials, because of the property of materials, they actually attract. And they bind together and they collapse into a single quantum mechanical state. If you put a magnet above a superconductor, the magnet will float. Why is that? Well, it turns out magnetic fields can't permeate a superconductor. So they cancel that magnetic field. They repel that magnetic field.
Superfluidity is
And so, if the polar ice caps ever melt, that's when all the spaceships will levitate off the planet because the ice that was keeping them super cooled will be gone, and then all the magnets will push those up into the stratosphere and we'll see the aliens that have been here forever.
another quantum mechanical phenomenon in which a liquid loses all viscosity and flows with absolutely no friction and without any loss of kinetic energy.
It's goopy.
Bose-Einstein condensates, also called the fifth state of matter, is typically formed when a gas of bosons at low densities is cooled to temperatures very close to absolute zero. Under such conditions, a large fraction of bosons could occupy the lowest quantum state, at which point microscopic quantum mechanical phenomena, particularly wave function interference, become apparent macroscopically. Physicists behind NASA's Cold Atom Lab, which began operating in the International Space Station in 2018, have shown that the laboratory can successfully exploit the microgravity of space in ways that allow scientists to create phenomena that would be impossible on Earth. The facility is on track to become the coldest place known in the universe.
Wow.
Although the first quantum phenomena were observed more than a century ago, scientists are still learning about this realm of our universe. More on that in another video. Thanks for watching.
No!
Did you like this video? Then
No, you ended too soon. Okay. Interesting. And of course, this is just the weirdness of quantum physics. This is like a very brief primer, right, on the weirdest parts of it. That was interesting. I don't know that much about quantum physics, so for me, that's like, you know, some of it I kind of got, and some of them was like, what the hoodoo? I didn't understand the whole, we're spinning this way absolutely in every direction at once, but then it makes something spin over here, and you spin, you throw up, like we were on a bender last night. Okay, it looks like the next video is going to be about gas giants. What should I search for? I should probably search for the name of the channel. 26... No, not T. Ah, shit. 26. 26 dimensions. That's it. And what's the name of the video? It's called The Gas Giants Explained. I clicked on it and played it a little bit, but it's not here. But we do have some Big Bang Theory. Anyway, so 26 dimensions. Shit. 26 dimensions. Gas. Giants. Gas giants. There it is. Okay. Gas giants in 15 minutes. The gas giants, of course, the biggest planets in the solar system that are supposedly just made entirely of gas. You can't, like, touch down on them because there's no solid ground, right? Let's find out about these.
As of today,
I hit play earlier just to get a little bit of preview. Here we go.
2 of the gas giants can be seen from space, and all 4 of them are gargantuan balls of rapidly spinning atmospheres of gas around small, rocky cores.
So they do have a rocky core. See, I didn't even know that.
The ancients recorded them and believed they represented their gods.
I'm gonna lower my headphones too, it's pretty loud.
As of today, we know some of their moons may harbor conditions favorable to life as we know it.
Oh, really?
The gas giants are a lot more than blobby balls of color in the night sky. So in this video, let's take a dive into the world of these cosmic behemoths to find out how they formed and what they look like from the inside.
You know what freaked me out recently when I was playing that game Outer Wilds, and one of the planets is a gas giant. You go into it and you're like, oh my god, it looks so different once you get through the atmosphere, and there's all this crazy shit going on with water and gas squirting everywhere. That freaks me out. I wonder if that's exactly what it's like once you get past this, like, atmosphere of, say, Jupiter or whatever. Because that's Jupiter right there, right? recognize the big spot.
Our solar system is home to 4 enormous gas giants: Jupiter, Saturn, Uranus, and Neptune, in order of distance from our star, the Sun. They hang in the space between the asteroid belt and beyond the 4 rocky planets of which our Earth is one. Each gas giant consists almost entirely of gases, mostly light ones like hydrogen and helium, and compared to their huge sizes, they have relatively tiny rock cores.
So what caused the gas to formate on
Their
those
differing
cores?
chemical compositions give rise to their distinct colors, atmospheres, and behavior.
Yeah, this is interesting. I hope we learn about it.
And because we're almost certain that the gas giants have small rocky cores, many astronomers believe that the gas giants originated as little solid planets during the formation of our solar system, but quickly pulled huge volumes of hydrogen and helium away from the accretion disk of myriad gases surrounding our fledgling sun. Once the sun had stabilized, it blew most of the remaining gases away, leaving us with the gas giants, similar to how they appear today.
Wow, that's interesting. I didn't know they came out of the sun.
While Jupiter and Saturn hold enormous volumes of hydrogen and helium in their gravity, Neptune and Uranus contain greater volumes of much heavier, more volatile gases. These are often called ices, and the discovery has led to Uranus and Neptune assuming their own categorization, the ice giants.
Oh, frozen planets.
Meanwhile, in Saturn's and Jupiter's atmospheres, heavy gases only account for up to 15% of their composition. Generally, Jupiter and Saturn look more violent and active from the outside. The characteristic clouds you see in Jupiter's and Saturn's atmospheres are caused by stripped and warped distributions of compounds like water and ammonia, and the rest of their atmospheres is hydrogen and helium. Because of the intense pressure in the gas giants, hydrogen is compressed so much that it becomes an electrical conductor. This has given it the name metallic hydrogen because of its conductive behavior. But do not be fooled, because there is nothing metallic about hydrogen. The closest gas giant to Earth is Jupiter.
Right.
Jupiter, being the largest planet in our solar system, can be seen with the naked eye if you know where to look.
I don't know if I've
As
ever
the
seen it with my
fourth
naked
brightest
eye.
object in the solar system after the Sun, our Moon and Venus, Jupiter was first recorded by the ancient Babylonians, one of the first human civilizations on Earth. The ancient Greeks believed that the planet represented their god Zeus, and the Germanic tribes thought it was their god Thor. With a
Always
radius
tying
11
religion
times
to
the
the
Earth,
stars.
Jupiter is composed of mostly hydrogen and helium, with a possible inner core probably the size of our home planet. Jupiter's clouds are full of ammonia crystals and sulfur, as well as probable traces of other compounds. Inside it has a liquid and a solid metal core, where the density is so high that the hydrogen becomes electrically conductive.
My apologies that I'm not saying much. It's just that this is, all data that I'm absorbing and learning. And I didn't know much of this. I mean, last time I'd learned anything about the planets was probably, I'm not even kidding you, probably like elementary school or like early high school days. So this is like the first time in in some cases 30 years I'm really thinking about this stuff. So I'm absorbing. I don't really have much to say because I'm learning.
In Jupiter's atmosphere fluctuates around negative 145 degrees Celsius.
Jesus.
With the center of the planet reaching possibly as high as 24,000 degrees Celsius.
What the?
Hotter than the surface of the sun.
Huh?
And wind speeds frequently reaching as high as 400 miles per hour.
Why would the center of Jupiter be hotter than the surface of the sun? How does that even make sense? If it came from the sun, how could it be hotter than the sun?
Twice the speed of the very strongest hurricanes on our home planet.
I don't know. I'm
Jupiter's
stupid.
Great Red Spot Storm has been raging for a staggering 186 years, and possibly as much as 3 centuries, and rotates at voracious speeds anti-clockwise, making a full rotation every 6 Earth days.
Well, it's quite large. So
Its
it
bright
takes
red
a while.
color is probably caused by organic red compounds, but scientists do not know for sure which chemicals make it look this way.
I don't blame them.
Jupiter is an extremely violent world and cannot support life, but its moons may have liquid oceans with favorable conditions for extraterrestrial life. Jupiter is pursued by a whopping 53 moons, with about 20 more awaiting confirmation.
Wow.
The largest of Jupiter's moons are Ganymede, Callisto, Io, and Europa. Many believe Europa has good conditions for life as we know it.
That's where we're going.
Though they are not nearly as visible as Saturn's, Jupiter does have its own set of rings. They are immensely hard to spot, so much so that they were only confirmed when the Voyager spacecraft flew by Jupiter in 1979.
Oh, didn't even know about them until the Voyager flew by.
Jupiter has been frequented by a total of 9 spacecraft, with the latest, Juno, having reached the gas giant in 2016. Because Jupiter is so large and has such a strong gravitational pull, spacecraft often perform special maneuvers to slingshot around Jupiter and away from our solar system to explore outer space.
Ah, use the gravitational pull to your advantage. Get momentum.
Jupiter's day is noticeably short at just 10 Earth hours.
Oh, wow.
Though its year is equivalent to 12 Earth years.
Oh, well, that's odd. Short days, long years, huh? Because the days
beyond Jupiter,
day-to-night cycle.
and you are bound to arrive at Saturn, a popular planet among many for its distinct rings.
Giant rings.
Named after the ancient Roman god of wealth and agriculture, Saturn can be seen by the naked eye from Earth, and is an enormous giant 9 times wider than our home planet. In fact, it is the furthest away planet that can be observed with the naked eye. Most of Saturn's atmosphere is hydrogen and helium, though the top layers consist heavily of ammonia ice, with wide bands of water ice and sulfur ice mixtures below. Near Saturn's core, the pressure is so high that the hydrogen becomes electrically conductive, or as it is known, metallic. In the core of Saturn, the enormous pressure solidifies metals like iron and nickel, as well as rocky materials at huge densities.
How would they know this? They send probes in there?
Winds in the ringed planet's atmosphere can reach a speedy 900 miles per hour. And Saturn has seasons extremely like Earth's because its tilt is almost exactly the same.
Ah, interesting. It's tilt
in 2017,
towards the sun.
The Cassini spacecraft ended a roller coaster ride of more than a dozen years studying Saturn to learn about its gravity and magnetic fields, as well as examining its distinct rings. Arguably, the most distinguishing feature of Saturn is its bright rings, which were first discovered by Galileo Galilei, and are the most extensive and widest rings of all the planets. There are 7 groups of rings, and they consist of a plethora of objects from the size of grains of sand.
It's like complex on top of
mountains.
complex on top of complex. There's 7 rings on top of this crazy elaborate
planet
planet.
has by far the most prominent rings of all the gas giants, and they can even be seen with the naked eye.
It's an eyeball, big floating eyeball.
At the end of the mission, Cassini dived straight into Saturn's atmosphere to learn about its composition. In total, 4 spacecraft have visited the ringed planet. It is not just orbiters that circle Saturn, though. Saturn is greedy with its moons, which number at least 53, with about 30 awaiting confirmation.
More moons.
They are home to some of the most spectacular scenery in our solar system. The largest of its moons are Titan and Rhea, both extraordinary worlds that have attracted a lot of attention by astrophysicists. And
if it actually has that many moons, in reality, if you were looking, because this is obviously a generation, this is not really footage, wouldn't you see all these moons around it? So you would never really get a clear picture of Saturn. You'd constantly be seeing, you know, a dozen or more moons at once kind of moving around it at any given point. You wouldn't get a clear shot at the planet like you're seeing in all these simulations, I think.
Space agencies. Enceladus is believed to have a liquid ocean somewhere beneath its frozen surface.
So it
One day
has
on Saturn
a liquid
lasts
ocean
less
on one of
than
the
10
moons.
Earth hours, meaning it has the shortest day of all the planets in our solar system. But its year is still significantly longer than ours, lasting about 29.4 Earth years. Uranus gets its name after the Greek god of the sky. Invisible to the naked eye when on Earth, Uranus was discovered by Sir William Herschel in 1781 from his garden, and he shrugged it off, assuming it was just a comet. He was wrong.
And embarrassed by all of his peers.
Uranus has a
What a
similar
fool.
chemical composition to our icy giant partner Neptune, with a mass around 14 times that of Earth. 8% of Uranus is constructed from an extremely hot and dense fluid. Like Neptune, this fluid is referred to as icy, even though it is far from cold.
Yeah.
And temperatures consistently reach over 4,000 degrees Celsius near the
Oh.
core's surface.
Oh, it's really chilly in there.
Uranus's core is comprised
bundle up.
of an amalgam of extremely solid compressed ice and rock. Fly up to Uranus's atmosphere, however, and the temperature can plunge as low as negative 200 degrees Celsius. Methane in Neptune's atmosphere absorbs the red wavelengths of visible light, giving it its blue color.
Oh yeah, blue color. Why are we seeing the
Unlike
Neptune statue right now?
Uranus has comparatively calm wind speeds, with maximum wind streams reaching
Why are
about
we looking at this?
360 miles per hour.
Thank you.
Still substantially faster than the fastest hurricanes on Earth.
Enough
But
stock
you will
footage
see,
of Greek
this
gods.
is not much in comparison to Neptune's winds. The Voyager 2 spacecraft, which also flew by and inspected Neptune, looked at Uranus to gather scientific data.
But it was embarrassed looking at such
Uranus
a huge
appeared
butt.
very bland and inactive. Although it has a somewhat similar color and composition to its partner Neptune, it does not exhibit the same storms and atmospheric behavior.
Ah, pretty stable.
A day on Uranus lasts 17 hours. Its year lasts a lengthy 84 Earth years.
Whoa.
That means Earth makes 84 full orbits around the Sun in the time it takes Uranus to make a single complete orbit.
Damn. Takes a million,
Uranus's
long, long
axis of
time.
rotation is tilted so far that it nearly intersects its plane of orbit. So it is essentially spinning on its side, though that term is sort of meaningless when we're talking about space,
Yeah,
where there is
no
no
side.
up or down.
Right.
This does not mean that the tilt doesn't have consequences for Uranus, though. Because Uranus's rotational axis is almost parallel to its plane of orbit, it experiences vicious, literally polarized, pun unintended, seasons, where one pole of the planet leans directly towards the sun and is heated far more than the other half of the planet, which has its back towards the sun and is far colder.
Jeez.
Therefore, Uranus essentially has two long evil seasons.
Yeah.
Each pole experiences 42 straight years of endless sunlight before 42 years of cold darkness.
Yikes.
For
That would
some
be a hell of a
strange
life.
reason, however, the equator of Uranus is substantially hotter than the poles, which goes against common sense. The exact reasons for this temperature distribution are yet unknown.
Huh. I'm sure there's a lot of things we just can't explain right now.
After cruising by Uranus, the Voyager 2 craft flew by Neptune in 1989, becoming the first and only spacecraft to visit the watery planet.
So that's why it's called
Named
Neptune.
after the
it's water.
ancient Roman god of the sea,
Right.
Neptune has clearly earned its name, as its gaseous body is extremely violent and prone to storms.
Stop showing
A
the
notable
statues.
trait of the Roman god.
Stop that. I see it. I
Although
know.
it
I know
cannot be
Neptune.
seen by the naked eye, Neptune exhibits a very bright bluish-green color due to some unknown chemical in its atmosphere. Resembling Uranus's structure, Neptune homes large volumes of liquid water and ammonia in the lower layers of its atmosphere, giving it the nickname the watery planet. Neptune's inner sea beneath its thick atmosphere is called the water ammonia ocean and is electrically very conductive. Life here is deadly. It is thought that the pressure in Neptune's atmosphere is so strong that methane is decomposed into tiny diamond fragments, which are continuously flung towards the ocean.
So, if you were past that layer of atmosphere, you'd be immediately ripped apart by diamond fragments going through space. You'd be done. Torn apart to pieces. Damn.
The temperatures can reach as high as 5,000 degrees Celsius, and the lower fluid is immensely hot and dense, even though it is often referred to as icy.
Hot and dense, but referred to as icy.
Theories
Why are you
regarding the
referring to it as
formation
icy
and
then?
behavior of the gas giants suggest that Neptune's core is composed of iron, nickel, and a variety of silicates.
They love iron and
It is
nickel out there.
estimated that the core weighs a little more than Earth. At the core's surface, the atmospheric pressure is 100,000 times stronger than Earth's atmosphere.
Take a look at these early
Ferocious
1980s
winds rip through
diagrams.
the gas at 9 times the power of the strongest winds on Earth. Neptune is like Jupiter in that it suffers enormous brutal storms throughout its year. When Voyager 2 passed Neptune in 1989, it detected a powerful storm so large it could have fit the entire planet Earth inside with space to spare. Voyager 2 also confirmed Neptune's faint rings, which had been inconclusive for many years previously.
It's got rings too.
It found that Neptune has a series of 5 large rings and at least 4 smaller arcs.
So why don't they animate them here?
A Neptunian day lasts 16 hours, but its year is extremely long. 165 Earth years, in fact.
Nice.
Though its magnetic poles are supposed to complete a full rotation every 16 hours, the equatorial zone of Neptune's atmosphere can drag behind, taking up to 18 hours. Because Neptune is angled in relation to its orbital plane at 28 degrees like Earth, it has its own seasons. But because Neptune's year is so extraordinarily long, each season lasts a staggering 40 years.
Wow.
About every 250 years, Pluto's orbit crosses Neptune's, bringing it closer to the Sun than Neptune for about 20 years.
Interesting. Interesting, there's four planets that are all gas giants. They're all like totally different, right? They're barely even similar with their composition and the way that they behave and then, you know, everything. Pretty wild. Will we ever get out there? Will we ever actually do anything with them? Probably not. All right, the last video for this react, or to react to, I should say. It's a short one. Life on gas giants. Life on gas giants. There it is. 4 minutes. Let's take a look. What's it like to live on a gas giant? I'm gonna guess not very pleasant.
Life, but actually,
wait, I just rewound you. Stop that right now. Play. How dare you argue with me? Damn you, YouTube video.
gas giants are not solid, of course. And because of that, we generally tend to overlook them when we are thinking of alien life. But actually, there is a possibility that there is such alien life even in our galaxy. Carl Sagan was the first one to really popularize this idea of life on gas giants, and he reasonably explained that laws of physics do not stop such life from evolving somewhere in the universe. So let's take a look at how that alien life would even operate. So the most simple life forms present on gas giants would most likely be tiny organisms that would use the organic compounds present in the atmosphere of their planet. But the one problem would be that they would fall downwards towards the center of the gas giant and fry due to pressure and temperature. But what is possible is that these tiny organisms could reproduce in mass, and some of the extreme winds present on the gas giants would pick up some of the organisms that were falling and lift them back to the top of the atmosphere. And that process could pretty much go on for billions of years. This is the most simple ecosystem imaginable, and there likely are many such gas giants in the universe with such life forms present on them. But let's not stop there, since there could be much more complex systems.
That's interesting. So
that in some
creatures that never touch anything solid, they're always just in the air, in the atmosphere forever, reproducing in the air, living in the air. If they get sucked down, they die, but they reproduce at such great volume that a lot just stay up in the air. That's very interesting.
Some of the gas giants, from simple tiny life forms, evolved an organism that could float on the atmosphere and would pretty much not have a problem with falling down. As Carl Sagan said, these floaters could be gigantic, the size of cities, and one of the reasons these floaters could get so big is because gas giants have enormous surfaces. For example, the surface area of Jupiter is 120 times larger than the surface area of the Earth, and because of that, there is much more room for life, similar to how fish grow bigger in bigger fish tanks. So yeah, floaters could get enormous and could feed off from organic compounds present and from the sunlight.
It could literally eat the other things we were just talking about. If you have a giant floating thing that looks like a giant pad, and it just sucks all the things out of the atmosphere under it and it stays above the atmosphere. Huh. Cool.
Could evolve hunters, which would
Hunters.
naturally keep the population of floaters in check
Oh.
so that it doesn't get overcrowded on the planet.
Damn, it's
But
getting
let's
exciting
imagine
down there.
An even more complex system. Let's say a system as complex as the one on the Earth, where you have many species all co-evolving with each other. Such an environment may be present, and out of that complex environment could evolve and rise single species that are self-conscious and as intelligent as us humans. But of
So
course,
why has anyone wrote a manga or anime about this? Life on Jupiter, the floaters, the hunters, the atmospheric creatures, and the hyper intelligence that live among them. I want to read
completely
that.
different form. Now, despite the fact that they could be as smart, the environment that they are in offers less opportunity to build and find
Right.
innovations because it is all gas. But maybe these intelligent species that evolved out of this environment could maybe find a way to build a pond in the atmosphere present there and would get more advanced and possibly leave their gas giant planet and settle anywhere else. That would be pretty amazing. And remember, laws of physics do not prevent such a crazy thing from even happening. So, considering that we, as of right now, know that there are 2 trillion galaxies in the universe, and that each galaxy has an average 100 billion stars, and that
Oh,
each
is that
star
all?
has a planet, or at the very least, every 10th star has a planet, then we can conclude that in a universe this big, that such a thing described here may even exist.
Cool. So what they're saying is don't just think that life can only exist on a planet that's like Earth. Even these crazy gas giants that you would think are uninhabitable could be inhabitable, but it just wouldn't be by creatures like us. It would be completely different styles of creatures. They could even be as intelligent as us, but because they can't live in the same kind of situation as us, they don't have solid ground, gravity, none of that. They can't live on it because if they go sucked inside the planet, they die. So they're just a completely different form of life that could still be smart, but just different. Interesting. All right. I hope you enjoyed this private react. That was good, and interesting for sure. I wonder if this will keep up because these really make me think in a way that usually I don't think ever about this kind of stuff. So it's a lot different and it's very interesting to me. Thanks so much for your support on my Patreon, and I hope you enjoyed the video. And anyone else who ends up watching this, if you do, hope you had a good time. Just like me. Sorry I don't talk too much over this kind of a subject matter, but man, I learned so much and I absorbed so much. It's just fascinating. Awesome. Thanks.